Hello students, so in this video we'll solve the MCQs of electromagnetic induction, chapter number 6. Fine. See the first one. What is the unit of self-inductance? Self-inductance is basically having two formulas. Self-inductance is equals to N phi by I, or EMF is minus L di by dt, right? Okay. So accordingly, the unit will be, N represents the number of turns, it won't have any unit. 5 represents the magnetic flux, unit of flux is Weber or Tesla meter square. Unit of current, that is ampere. So one of the unit of self inductance is Weber per ampere, and other one, from this L can be written as E into dt by di. L is equals to E into dt by di. Unit of E, volt second per ampere. So self inductance will have the unit Weber per ampere, volt second per ampere, even Henry, Tesla meter square per ampere. There are many units of self inductance, right? So check the option volt second per ampere, it is given in your B option. So this is your correct option. Clear? The next one, second one. 3 inductors each of 3 millihenry are connected in series with a variable voltage source. What is the equivalent inductance? Inductor will act like resistors connected in series, right? So there are 3 inductors connected in series with a variable voltage source. That means current is changing. Current is changing. Let the self inductance be L1, L2, L3. They are all of 3 millihenry. So in series, current will remain same. That means rate of change of current di by dt will also be constant for all the 3 inductors. Fine. So here let the voltage drop be E1, E2 and E3. So equivalent EMF will be E1 plus E2 plus E3, right? E1, that will be minus L1 di by dt, minus L2 di by dt, minus L3 di by dt. Got it? Okay. So minus di by dt is taken common. This will be L1 plus L2 plus L3. Now what is minus E by di by dt? L equivalent. L equivalent. So finally L equivalent is equals to L1 plus L2 plus L3. L1, L2, L3 are given as 3 plus 3 plus 3. So your answer will be 9 millihenry. Clear? Fine. So A is your correct option. Okay. The next one. Third one. At t equals to pi by 2 omega, what will be the EMF generated in a AC generator? Okay, so for an AC generator, EMF was NAB omega sin omega t, right? And flux was NAB cos omega t. Clear? So we want the EMF generated at t equals to pi by 2 omega. Substitute here. So EMF will be NAB omega sin omega into time is given as pi by 2 omega. So this will be sin pi by 2. Sin pi by 2 is 1. So EMF generated at a time interval of pi by 2 omega is NAB omega. That is the maximum EMF is generated at this particular instant of time. So A is your correct option. Clear? Fine. The next one. Fourth one. Current in a circuit falls from 5 ampere to 0 ampere. Okay. So initially current was 5 ampere and then it reduces to 0 ampere. So delta I will be, you can say, minus 5 ampere. In time interval of 0.1, okay, 0.1 second is the time interval. If an average EMF of 200 volt is induced, so you are having an average EMF of 200 volt. EMF is induced because current is changing. If current changes, magnetic field will be changing, flux will be changing, and EMF will be induced, right? Fine. So what is the self inductance? So EMF is equals to minus L, average EMF is equals to minus L delta I by delta T. This is given as 200 minus L. What is delta I? Minus 5. What is time? 0.1. This will be plus. So 200 is equals to L into 5 by 0.1, that will be 50. So L will be equals to 4 Henry. So self inductance is 4 Henry. So D is the correct option. Clear? Fine. The next one. Fifth one. This is very easy. Lenz's law is based on conservation of. It is to know the direction of induced current in the loop, right? Right? We can find the direction of current with the help of Lenz's law, and it's based on conservation of energy. Lenz's law is based on conservation of energy. Clear? The next one. Okay, so sixth one. Current flowing in the wire is decreasing at a constant rate. What is the direction of induced current in the loop? Fine. Say current is decreasing at a constant rate. This is a wire where current is flowing and it is decreasing at a constant rate. So we need to find the direction of induced current in the loop. Make it clear, the loop is not placed above the wire. It is not placed above the wire. It is placed beside the wire. Okay. From Lenz's law, we'll be able to know the direction of induced current in the loop. So this is what the question says. Current is flowing through the wire and it is decreasing at a constant rate. The loop is placed over here, right? So because of this wire, the magnetic field produced will be in vertically upward direction. Current is in this direction, so magnetic field produced in the loop because of this wire will be in vertically upward direction. Now current is decreasing in the wire. So from Lenz's law, in the loop, current will be induced in such a way, in such a direction that its magnetic field will be also in upward direction. According to Lenz's law, it will be in such a direction that it will oppose the cause producing it, right? That means if flux is increasing, then current will be induced in such a way that its own magnetic field will be in the direction opposite to the original magnetic field. Here presently it is given that the current is decreasing at a constant rate. Current flowing through the wire is decreasing at a constant rate. That means you need to think the direction of current such that its own magnetic field will be in upward direction in order to support. Once again, say current is flowing in this direction, right? And it is decreasing. Fine. So because of this current, the magnetic field in the loop will be in vertically upward direction. Now, the direction of current in the loop will be such that its own magnetic field will also be in upward direction. That means the direction of current should be this way. In the loop, if current is flowing in this direction, that is in anti-clockwise direction, right? In anti-clockwise direction, then its magnetic field will be in upward direction. Clear? That means since flux passing through this loop is decreasing, so think about the direction of current such that its magnetic field will be same as the magnetic field of this wire, right? So current will be this way, in this direction. Got it? So current will be flowing in an anti-clockwise direction. See, there is a shortcut for this kind of questions. That means if it is given that current is decreasing, then the direction of current will be same as the direction of the flow of current in the wire. If in the question it is given that current is increasing, suppose, then the direction of current in the loop will be opposite to the direction of the current in the wire. Clear? This is a way to solve this kind of questions. Presently our answer is anti-clockwise direction. Fine. So the next one. Okay, so seventh one, flux passing through the coil of resistance 2 ohm changes from 2 Weber to 8 Weber. That means initially the flux is of 2 Weber and it then changes to 8 Weber. So final flux is 8 Weber, initial is 2 Weber. And resistance of the coil is given to us, it is of 2 ohm. Find the induced charge. Okay, so this is formula based MCQ. induced charge delta Q is change of flux by R. Induced charge does not depend on rate of change of flux, it just depends on the change of flux. So change of flux, that is final minus initial divided by R. So that is 8 minus 2 upon 2. So this is 6 by 2, 3 coulomb. This is a formula. So your answer is option C, 3 coulomb. Clear? This was very easy. Find the next one. Okay, the 8th one. What is the dimensional formula of inductance? Dimensional formula of inductance. Okay. So n phi proportional to I, n phi is equals to a proportionality constant into I. This proportionality constant is known as inductance, right? Suppose if I am putting L, this will be self-inductance. It's okay. I mean, self-inductance and mutual inductance will have the same dimension formula. So finally, L is equals to n phi by I. So unit will be unit of self-inductance was volt second by ampere. Yes, volt second, or you can say yes, Weber per ampere. All means the same. Fine, volt second by ampere. Now the dimension formula of volt is, what is the formula of volt, definition of volt? Potential difference is work by charge, right? So this will be M1 L2 T minus 2 upon A1 T1, right? So we will have the dimension formula M1 L2 T minus 3 A minus 1, right? Put the value over, put the dimension formula over here. So L will have the dimension formula as, instead of V, we'll write the dimension formula M1 L2 T minus 3 A minus 1 second. So that will be T1 upon ampere, that will be A1, right? So finally the dimension formula of inductance will be M1 L2 T minus 2 A minus 2. This will be the dimension formula of inductance. M1 L2 A minus 2 T minus 2. 1 2 T minus 2 A minus 2. That means this B is the correct option. M1 L2 T minus 2 A minus 2. This will be the dimension formula for inductance. Clear? Fine. The next one. Okay, 9th one. AC generator works on the principle of, what is the concept of AC generator? A change of flux. The coil will rotate at a particular frequency omega between the two poles of a magnet. So there will be a change of magnetic flux passing through the coil, right? And because of that, EMF will be generated. Current will be flowing. So it works on the principle of course, electromagnetic induction. A change of magnetic flux will produce EMF, which will produce current, right? So A is the correct option. Okay, fine. The next one. Okay, 10th one. A conducting rod of length 2 meter is kept in north-south direction and is allowed to fall freely. Okay. What is the EMF developed in the rod when it is at a height of 20 meter from the ground? Okay. Take G as 10. The Earth's magnetic field is given 5 × 10 raised to minus 4 Tesla and dip angle is given as 30 degrees. This is the dip angle. Okay. Fine. So this is ground, right? Rod of length 2 meter is kept in north-south direction. Conducting rod is kept in north-south direction. This means, it means this way, and then it is allowed to fall freely. Okay, the EMF developed in the rod when it is at a height of 20 meter from the ground. See, okay, so the length is given as 2 meters. So this is given as 2 meter length, and it is falling freely. So velocity is also in downward direction. Initial velocity will be 0. And then the velocity will be in downward direction. Fine, and the magnetic field is given 5 × 10 raised to minus 4 with a dip angle of 30 degree. Okay, so this will be the horizontal component, this will be the vertical component. Actually, since the rod is performing motion, there are chances that the motional EMF will be induced in the rod. But for motional EMF, we need to check the condition whether velocity is perpendicular to B and velocity is also perpendicular to L. If these two conditions are satisfied, only then EMF will be induced in the rod. That means you are using this formula, E is equals to BVL or minus BVL. This is the formula to calculate the motional EMF, right? But the motional EMF will be induced only when V is perpendicular to B and V is perpendicular to L. These are the two conditions for motional EMF. Okay. Presently in our question, okay, see, B of H is in this direction. B of H, that is the horizontal component. Actually, it's okay, fine, no problem. B of H is in this direction, velocity is in this direction. So V is perpendicular to B of H, that is okay. But both V and L are in same direction. Velocity is also in downward direction and length of the rod is also in the, that means this is the length, this is the length, and velocity is also in the same direction. So V and L are not perpendicular to each other, right? That means this condition is not satisfied, so there will be no EMF induced in the rod, right? So at present in our question, EMF induced will be 0 because the condition for motional EMF is not satisfied. Okay, if the rod is kept in east-west direction, then if this is how the rod is kept, then see, then the condition of motional EMF is satisfied. See, this is the length, this will be the velocity. So V is perpendicular to L, of course, and V is also perpendicular to B of H. It is not perpendicular to B, but it is perpendicular to B of H. So if the rod is placed in east-west direction, then of course EMF will be induced, right? Then EMF will be induced, which will be equals to BH VL, that is B cos phi into velocity into length. Because why I have taken B cos phi? Because it is the component, B of H is the only component which is perpendicular to the velocity of the rod. So whenever you are using the formula BVL, first check these conditions, that whether V is perpendicular to B, V is perpendicular to L. If both the conditions are satisfied, only then EMF will be BVL. Yes, one more thing. If V is not perpendicular to B, but if V is perpendicular to any of the component of B, then also it will be okay. Like here, V is not perpendicular to B, but V is perpendicular to B of H. So that will work out, and that is why I have taken B of H and I have not taken B. Clear? Clear? But in our case, the rod is not placed in east-west direction, it is placed in north-south direction. So both length and velocity are in same direction. So the condition of motional EMF is not satisfied. So our option will be B, that is 0. Fine? Okay, the next one. Okay, so 11th one. When rate of change of current is 1 ampere per second, then mutual inductance is equals to, fine, this is very easy. When rate of change of current, that is di by dt, is 1 ampere per second, that is di by dt is 1, then mutual inductance is equals to, okay, we are having the formula minus m di by dt, minus sign is just because of Lenz's law, right? Presently di by dt is 1, so EMF will be equals to mutual inductance, or mutual inductance will be equals to the EMF produced. So B is the correct answer. Clear? Since di by dt is 1, so then EMF is minus m di by dt. This term is 1, so m will be equals to EMF. Done? Fine. The next one. Okay, 12th one. For a long solenoid, if number of turns are double, that means in a solenoid, if I am making the turns double, what will be the self-inductance? Okay, see, self-inductance is N phi by I, right? Okay. So from here, don't directly write it as L proportional to N, no. Still, flux will be equals to B dot A, and B is mu naught Ni by L into A, right? So finally, self-inductance L will be N by I into mu naught Ni A upon L. So L is equals to mu naught N square A by L. If area, cross section area and length, if they are taken as constant, then self-inductance is proportional to square of the turns, N square. So now if turns are made double, then self inductance will be square of 2, that will be 4 times. So this is the correct option, 4 times, right? So from this formula, don't directly write it as L proportional to N. L is proportional to N square for a solenoid. Fine. So we have completed the MCQs of this chapter, and in the next video we'll solve the MCQs of the other chapter, that is alternating current, chapter number 7. Okay, thank you.